This is Mrs. Boots, and we're going to work through the practice problems for multiplying rational expressions. Remember, there are 3 basic steps: factor, cancel, write what's left. For factoring, you don't do monomials. Basically, anything but a monomial is factored. Okay, let's look at example or problem 1. So in problem number 1, we have monomials, top and bottom. We know they're monomials because there's no addition or subtraction signs in between variables and numbers. So we can just go through and cancel out like things. I have 120 divided by 5. So what is 120 divided by 5? Well, that's just going to be 20. It goes in the position of the bigger number. 120 is bigger than 5, and it's on top. So my answer goes on top. Now let's look at our x's. I have 5 plus 1 on top, which is 6, and 3 in the denominator. So 6 in the numerator, 3 in the denominator. Numerator is going to win by 3. Now let's look at the y's. I have 4 in the denominator and 1 in the numerator. Denominator is going to win by 3. Number 2. Again, all monomials, but that's okay. Look at the coefficients. I have 5 and 15. 15 is divisible by 5 3 times. Where's the 3 going to go? In the denominator, because that's where the 15 is at. Now look at the x's. I have 3 on top, 2 in the bottom, and then I have another 2 in the bottom. So 3 on top with 4 in the denominator. So the x is going to be in the denominator. 4 minus 3 is 1. Now let's look at the y's. I have 4 total. 1 plus 3 is 4 in the numerator and 2 in the denominator. So my y's are going to be in the numerator. 4 minus 2 is 2. Number 3. Okay, this one's a little different. We have that x minus 3 out front. Remember, it's in the numerator if it's not written. So now I've got x squared minus 4 and the x squared minus x minus 6. Both of those can be factored. Let's do the numerator first. I see that they're both perfect squares. The square root of 4 is 2. So I have a plus 2 and a minus 2. Now for the denominator. What 2 numbers multiply to give me 6 and subtract to give me 1? Okay, I'm going to have a 3 and a 2. Which one's positive? The 2 is positive because the 3 has to have the same sign as the middle. Now let's see what cancels. Well, the x minus 3 out front cancels with the x minus 3 in the denominator. The x plus 2 on top cancels with the x plus 2 on the bottom. So the only thing left is that x minus 2 in the numerator. We do not need to put it over 1, it's understood. Number 4. Okay, first fraction, a plus 3, can't factor it anymore. No GCF, and it's not squared. The denominator is a plain number. Second fraction, 6 is a plain number. The denominator, however, does have a GCF. That would be a 3. So let's pull a 3 out of both terms. I'm left with a plus 3. That looks familiar. Okay, so my a plus 3's are going to cancel top and bottom. Now let's see what's left. I have a 6 in the numerator and 2 times 3 in the denominator. Yes, I know. That's 6 over 6. What is 6 divided by 6? 1. A really simple answer for a really complex problem. Number 5. I see a lot of factoring. So let's just dive in. Numerator of the first fraction. I need 2 numbers that are going to multiply to give me 8 and subtract to give me 2. That's 4 times 2. Which one's going to be negative? The 4, because the middle term is negative. The denominator of the first fraction has a GCF. I can pull a 6 out of both numbers. The first term, I'm left with an x. and 18 divided by 6 is 3. Now for the second fraction, the numerator. Well, both terms have an x, so I have a GCF of x. I'm left with x plus 3. Now the denominator. I need two numbers that multiply to give me 8, only now they're going to add to give me 6. It's still 4 and 2, but both of them have a plus sign in this case. Now let's see what's going to cancel. I notice I have the x plus 3 on top and bottom. I have an x plus 2 top and bottom. So let's see what's going to be left. I have an x minus 4, a plain x, a 6, and an x plus 4. No, we can't cancel out the x plus 4 and x minus 4. We're just going to have to write them down. So in the numerator I have x times x minus 4, and in the denominator I have 6 times x plus 4. Number 6. The first thing I notice is that the first term doesn't have a denominator. Just to make sure I don't mix it up, let's put it over 1. Now let's factor it. X squared, 8x, and 15. I need two numbers to multiply to give me 15. That's 5 times 3. Now because we're adding them, they have to both have the same sign as the middle. Plus and plus. Now the second fraction. The numerator is a constant, so we don't factor that. The denominator, however, has a GCF of 2. That leaves me with x plus 3. So what's going to cancel? Well, the x plus 3's, of course. But notice we have a 4 on top and a 2 on bottom. So 2 goes into 4 twice. Now let's see what's left. I have an x plus 5 and a 2. Both of them are in the numerator. So my answer is 2 times x plus 5. You don't need to distribute, just leave it as factored form. Number 7. Okay, I see a lot of factoring going on here. Numerator of the first fraction. X squared minus 4. We've done that a couple times, right? Yep, it's just x plus 2 times x minus 2. The denominator of the first fraction. Wow, what multiplies to give me 1? Well, it stumps some people, but it's actually super simple. It's just 1 times 1. And it's a perfect square, so we have the plus minus case. Second fraction, the numerator is already factored. The denominator, I can pull out a GCF. So I'm going to pull out an x, and I'm left with x plus 2. It's okay that it all runs together. That's not a big deal. If it bothers you, put parentheses around the x. Now let's see what cancels. I have an x plus 1 and an x plus 1. I have an x plus 2 and an x plus 2. Remember, you have to have 1 on top and 1 on bottom. Now let's look at what's left. I have an x minus 2, an x, and an x minus 1. So in the numerator we have x minus 2, and in the denominator I have x times x minus 1. This is the simplified rational expression. Number 8. Okay, one step at a time. I see that we have a GCF in the numerator of the first fraction, 2x. When I pull out 2x, I'm left with x minus 3. Now the denominator. I need two numbers that multiply to give me 81 and add to give me 18. Oh, that's easy. 9 times 9. Well, they both have to be positive in order to add to give me the 18. Now for the second fraction, the numerator. First thing most people want to do is write down x plus 9, x minus 9. But notice this is a GCF. I pull a 9 out of both terms and I'm left with an x plus 9. Now let's look at the denominator. The square root of 9 is what? 3. So I have an x plus 3 and an x minus 3. Every now and then somebody will go crazy and write x plus 9 and x minus 9. because they got 9s all in their head. The problem is 9 times 9 is definitely not 9. Okay, so what cancels? Well, the x plus 9s are gone. The x minus 3s are gone. Is there anything else? Let's circle. I have a 9 times a 2x, an x minus 9 times an x plus 3. Nope. So let's write it down. 9 minus 9 times 2 is 18. So I have an 18x in the numerator. In the denominator, I have my x plus 9 times my x plus 3. Number 9. Start with the first fraction, the numerator. I need two numbers to multiply to give me 4, and they're going to subtract to give me 3. Well, that's got to be 4 and 1, because 4 minus 1 is 3. The middle term's positive, so the 4 is positive, and the 1 will be negative. The denominator. Now I need two numbers that multiply to give me 4 and add to give me 4. Well, that's easy. That's just 2 times 2. Notice since they're adding, they both get the same sign, and that sign is positive. Second fraction. Numerator. There's no constant, so I'm going to look for a GCF. Yes, they're both divisible by 2x. That leaves x plus 2. Now let's look at the denominator. X squared minus 4x plus 3. So I need two numbers that multiply to give me 3. Well, that's easy. It's just 3 times 1. But in this case, they're both going to be negative because the middle term is negative. Now let's look at what cancels. An x plus 2 is on the bottom and the top. An x minus 1 is on the bottom and the top. Is there anything else that would cancel? Well, let's look at what's left. I have an x plus 4, a 2x, an x plus 2, and an x minus 3. Nope, those are all unique. So we write them down. In the numerator, I have 2x times x plus 4. In the denominator, I have x plus 2 times x minus 3. Number 10. Let's start factoring. Oh, the first fraction looks really weird. I have a cube there, but notice both terms have a d. So I'm going to do a GCF. GCF of 4 times d. That would leave d squared in the first term and just a 1 in the second term. Always remember to put the 1. You can't forget it. The denominator, however, is not factorable. It's just a monomial. Second fraction. I have a monomial on the top, so again, I'm not going to factor it. In the bottom, I notice they both have a 7. Is there anything else I can pull out? No. I'm left with d squared plus f. Okay, let's see what cancels. Well, it gets kind of crazy, huh? 4, 16, and 2. I notice I have two f's that are by themselves, so those will cancel out. 4 times 2 is 8, and 8 will go into 16 twice. So the 4 and the 2 are gone, and now I have an 8 in the denominator. But what about all these d's? Nope, the d's and the f's that are there stay. Okay, let's write what's left and double check it. In the numerator, I have a d times d squared plus 1. In the denominator, 8 times 7, that gives me 56, times d squared plus f. Did I miss anything? Nope, that's it. Number 11. Start with factoring. First fraction, the numerator. GCF, x. When I pull out an x, I'm left with x plus 3. The denominator. What multiplies to give me 8? We've done this a few times. It's 4 and 2, and they're both going to be positive. Now the second fraction. What multiplies to give me 2 in the numerator? Well, that's just 2 times 1. But we're subtracting, so which one's going to have the plus sign that's in the middle? That's right, it's the 2 because it's bigger. Now the denominator. This is looking pretty crazy, but it's okay. We're just going to pull out a GCF. What can I pull out of both? A 4 and an x. I'm left with x squared plus 3. Okay, so what's going to cancel? Well, let's see. We have an x plus 2 and an x plus 2. I have a plain x and a plain x. Anything else? Let's check. X plus 3, x minus 1, x plus 4, a 4, and an x squared plus 3. So no, everything's unique. So in the numerator, I have x plus 3 and x minus 1. In the denominator, I have 4 times x plus 4 times x squared plus 3. Number 12. Factor the top, the numerator of the first fraction. What multiplies to give me 3? Well, that's just 3 times 1. What's going to be the signs? The 3 is going to be positive just like the middle term, and the 1 is negative. The denominator is a little more tricky. I have a 3x and an x in front because 3x times x gives me 3x squared. So I have to figure out where the 2 and the 1 go because 2 times 1 is what multiplies to give the constant. You can play with it or you can do split the middle. It doesn't matter. I always use check and guess. So I fill in the numbers, multiply it out, and see if I got what I started with. Yep, that works. Okay, second fraction. The numerator's 1, so it's easy. The denominator is already in simplest form, so we can't factor it anymore. So what's going to cancel? X plus 3 and x plus 3 cancel. X minus 1 and x minus 1. So what's left? I have a 1 on top and a 3x plus 2 in the denominator. So it's 1 over 3x plus 2. Number 13. Numerator of the first fraction. GCF. 3x. What's going to be left? X plus 2. Second. The denominator of the first fraction. Well, that's the same as the denominator from the last problem. So 3x plus 2 times the x minus 1. The second fraction is super easy. So easy it's almost distracting. 2 simplified binomials. They don't even need factoring. Now, let's cancel. I have an x minus 1 and an x minus 1. An x plus 2 and an x plus 2. What's going to be left? 3x on top and 3x plus 2 on the bottom. Can we cancel the 3x's? No, we cannot. Remember, the denominator, the 3x, is attached to the 2, so it has to stay. Number 14. Wow, lots of coefficients there. That's okay. Let's just dive right in. Factor the first fraction's numerator. I'm going to have a 2x and an x. I need the 2 for the constant to multiply by the 2 from the x so that I get 4 and add 1 to get 5. The denominator. These are both perfect squares. The square root of 4 is 2, so I have 2x at the front. The square root of 1 is 1. Remember there's a plus and a minus. Second fraction. The numerator. Again, 2x times x is 2x squared. This one's easier because 1 times 1 is 1. But the signs get tricky. We want the 2 to have a plus sign, so it's got to be in the second factor in order to multiply and FOIL to give us that plus sign. Now the denominator. Oh good, an easy one. What multiplies to give us 2? 2 times 1. We're subtracting. The 2 has to be positive. The 1 is negative. Now let's see what's going to cancel. I have a 2x plus 1 and a 2x plus 1. Okay, I have a 2x minus 1 and a 2x minus 1. I have an x plus 2 and an x plus 2. That leaves me with an x plus 1 on top and an x minus 1 on the bottom. No, we cannot cancel out the x's and just divide the 1's. We have to leave them in. This concludes all the practice for multiplying rational expressions.